Dissolution by Jamie Mason, Sarah Yoon, and Jess Boone. What is the rate of dissolving? The rate of dissolving is a measure of how fast a solute dissolves in a solvent. This process is also known as dissolution. As you can see in the picture, a lump of sugar is dropped into a beak of water. Sugar molecules begin to break off from the lump. More and more sugar molecules move away and randomly bounce around. Then eventually, all the sugar molecules become evenly distributed throughout the water. What are the factors of dissolving? Solubility is determined by the intermolecular attractions between solvent and solute particles. The rate of dissolving, or how quickly a solute dissolves in a solvent, increases with four main factors: temperature, agitation, surface area, and the properties of a solvent. As temperature increases, the time it takes for the substance to dissolve decreases. As you see in this chart, the higher the temperature, the less time it takes to dissolve. Stirring and shaking increases the rate of dissolution and decreases the time it takes for the substance to dissolve. Stirring increases the rate of molecular reaction with its environment. So, activity that requires energy causes the agent that's being dissolved to react more quickly with the liquid. It is a physical catalyst that affects the rate of dissolving. Higher surface area decreases the rate of dissolution. The surface area exposed to the solvent determines the rate of which a solute will dissolve. For example, a large crystal of salt will not dissolve as quickly as powdered salt, because powdered salt has more surface area. As you crush a solid into smaller particles, you are decreasing surface area. Properties of a solvent. Like dissolves like, such as polar dissolves polar. For example, water has a higher concentration than oil. It refers to polar and nonpolar solvents and solutes. Polar substances will dissolve in polar substances. Nonpolar substances will dissolve in nonpolar substances, and nonpolar substances will not dissolve in polar substances. What is the opposite of dissolving? The opposite of dissolving is precipitate. This is because a substance will be deposited in solid form from the mixture, and it's due to certain properties of the solute and solvent.
Basically, when you mix two liquids together, it will create a substance that falls to the bottom.
And now it is time for the experiment video. For these experiments, you will need beakers, sugar, water, oil, food dye, hot plate, and stirring rod.
The way that properties of a solvent affects dissolution is by like dissolving like.
As you can see, the oil isn't mixing with the water, since oil is nonpolar and water is polar.
The way that surface area affects dissolution is by the smaller the surface area, the faster it will dissolve in a solution. As you can see, we have two of the same size cubes of sugar, but if I crush this up, creating smaller surface area, and add it, it should dissolve faster than the larger surface area. Now I'm going to add it in and see if it works.
As you can see, the surface area affects the dissolution. The smaller the particle, it would take faster to dissolve, and the larger the particle, it would take longer to dissolve.
The way that temperature affects the rate of dissolution is the higher the temperature, the higher the rate of dissolution. As you can see, we have a hot beaker and we have a cold beaker. If I take this off and add sugar into both, the same amount of sugar, as you can see, the sugar dissolves faster in the hot temperature compared to the cold temperature. The way that agitation affects the rate of dissolution is the higher the agitation, the faster the substance will dissolve. I have two beakers and I'm going to pour the same amount of sugar into each one. But if I stir this one, there will be less minerals at the bottom to show that there's more dissolution, a faster dissolution than compared to this one.